Welcome to Creative World. In this video, we will solve Chapter 3 Learning Assessment E3.23. While solving this problem, we will be using Kirchoff's voltage law. According to this law, sum of all supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Learning assessment E3.23. Find the value of voltage V0 in given below figure using mesh analysis technique. This is the circuit diagram of given problem. Inside this network, we have to find voltage across this 6 kilo ohm resistance labeled as V0. So without wasting time, let's proceed towards the solution of this network. First of all, in order to apply mesh analysis technique on any network, we have to find the maximum number of meshes that can be formed in that network. So using this equation B minus N plus 1, we can find the maximum number of meshes in this network. Inside this equation, B stands for number of branches and N stands for number of nodes. In this network, there are 10 number of branches and 8 number of nodes. So 10 minus 8 plus 1 will result 3. So maximum 3 number of meshes can be formed inside this network. Now we have to make 3 meshes inside this network and assume currents inside those meshes along with their directions. These 3 meshes are formed inside this network and the directions of currents are in clockwise direction. According to the directions of current, polarity notation across resistive elements are marked. Before we move further, we have to focus on this element of the network. This is a dependent current source and this current source exists between 2 meshes. Remember, in our previous videos, we discussed if a current source exists between 2 meshes, we cannot solve that network using simple mesh analysis technique. So in order to solve that network, we have to move super mesh analysis technique. In that technique, we open circuit that current source and apply mesh analysis on the rest of circuit. So before that, we have to find the current equation of this dependent current source. This current source exists between these 2 meshes and the direction of this current source is in downward direction, in the direction of current I1, and the value of this dependent current source is equal to the difference of these 2 currents, because these 2 currents are passing through this branch in opposite direction. That's why we have taken the difference of these 2 currents. So we can write this statement in mathematical form. The difference of these 2 currents I1 minus I2 will be equal to the value of this dependent current source 0.5 times Ix. Now here a question may arise, why we have subtracted I2 from I1? Why not I1 from I2? The answer is the direction of this dependent current source is in the direction of current I1, which is showing that current I1 magnitude is larger than I2. That's why the resultant current is in the direction of I1. If we focus on this equation, there is a variable exist Ix and the value of this dependent current source is depending upon the value of Ix. Ix in this network is this branch current and the direction of this Ix is upward direction, while we have assumed current through this branch is I3 and it is flowing in downward direction. Both currents are opposite in direction to each other, so we can say that current I3 will be equal to minus Ix, or Ix is equal to minus I3. Due to the series connection, both currents will have same magnitude of current, but the directions of both currents are opposite. That's why Ix is equal to minus I3. So replace Ix with its value I1 minus I2 equal to 0.5 times minus I3. Now open these brackets. The equation will become I1 minus I2 equal to 0.5 times I3 with minus sign. Place this value on the other hand side of equal. The equation will become I1 minus I2 plus 0.5 times I3 equal to 0. This is the first mesh current equation of this network. After finding out the current equation of this dependent current source, now we will apply super mesh analysis technique on this network. In super mesh analysis technique, we have to remove all current sources that exist or that are common between two meshes. In this case, only one current source is common between two meshes. So we have to remove this current source. And in order to remove any current source from the network, we have to open circuit it. So the circuit will form. This current source is open circuited in order to remove it from this network. Now, in order to apply KVL inside this network, we will use this path for first mesh. We will start writing KVL equation for this particular mesh. We will start from here. Current entering terminal of this resistance is positive. Now these two resistances are in series, so we can merge these together by adding the values of both resistances, and voltage across these resistances will be equal to the product of current I1 multiplied by the values of these two resistances, that is the sum of these resistances, 5 kilo ohm. Here, because we were in this first mesh, that's why we have taken current I1, but whenever we will switch to second mesh, we will take current I2. So voltage across this 4 kilo ohm resistance will be equal to the product of current I2 and 4 kilo ohm. Similarly, current entering terminal is negative, so 12 volt will be taken with the negative sign. Next, current entering terminal is positive, so voltage across this 6 kilo ohm resistance will be taken with positive sign. But for now, two currents are passing through this 6 kilo ohm resistance, and both are in opposite direction to each other. I2 is passing from right to left, while I3 is passing from left to right. And because we are in second mesh, so current I3 will be subtracted from I2. Voltage across this 6 kilo ohm resistance will be equal to the difference of these two currents, I2 minus I3 multiplied by 6 kilo ohm. Voltage across this 3 kilo ohm resistance will be equal to the difference of these two currents, I1 minus I3 multiplied by 3 kilo ohm. Next, current entering terminal is positive, so 8 volt will be taken with positive sign. Next, current entering terminal is negative, so 10 volt will be taken with a negative sign. Now subtract 8 volt from minus 10 volt, it will become minus 2 volt. Add that resulting minus 2 volt into minus 12 volt, it will become minus 14 volt. And place this minus 14 volt on the other hand side of equal to separate it from variables. So the equation will become 5k I1 plus 4k I2. Here brackets are opened. This 6 kilo ohm is multiplied with variables inside the brackets. 6k I2 minus 6k I3 plus 3k I1 minus 3k I3 equal to 14 volt. Add values having same variables together. The equation will become 8k I1 plus 10k I2 minus 9k I3 equal to 14 volt. It is the second mesh current equation of this network. Now we will apply Kirchoff's voltage law inside this closed mesh. We will start from here. Current entering terminal is positive, so voltage across this 6 kilo ohm resistance will be taken with positive sign. Again, this resistance is common between these two meshes, so voltage across this resistance will be equal to the difference of these two currents multiplied by the value of resistance. But for now, we are taking voltage across this resistance according to the direction of current I3. That's why current I2 is subtracted from I3. I3 minus I2 multiplied by 6 kilo ohm. Voltage across this 6 kilo ohm resistance will be equal to the product of current I3 and 6 kilo ohm, and these will be taken with positive sign because current is entering from positive terminal. Next, current entering terminal is negative, so 8 volt will be taken with a negative sign. Next, current entering terminal is positive, and voltage across this 3 kilo ohm resistance will be equal to the difference of these two currents multiplied by its value, I3 minus I1 multiplied by 3 kilo ohm. Now open these brackets, it will become 6k I3 minus 6k I2 plus 6k I3 minus 8 volt plus 3k I3 minus 3k I1. Now place this minus 8 volt on the other hand side of equal and add values having same variables together. The equation will become minus 3k I1 minus 6k I2 plus 15k I3 equal to 8 volt. It is the third mesh current equation of this network. Up to this point, we have retrieved three mesh current equations from this network which are labeled as equation A, B and C. In order to find the value of current I3, we will solve these equations. We are interested to find the value of current I3 because we have to find the value of voltage V0. It is asked in this scenario, and voltage V0 is equal to current I3 multiplied by 6 kilo ohm. In order to find the value of current I3, we will take this equation B as it is and will multiply equation A with minus 8k. This equation will become minus 8k I1 plus 8k I2 minus 4k I3 equal to 0. Now add these equations together. 8k I1 and minus 8k I1 will cancel out with each other. Sum of 10k I2 and 8k I2 will result 18k I2. Similarly, sum of 4k I3 and 9k I3 will become 13k I3. And on the other hand side of equal, 14 volt will left. Now we will take equation C as it is and will multiply equation A with 3k. This equation will become 3k I1 minus 3k I2 plus 1.5k I3 equal to 0. Add these equations together. Minus 3k I1 and plus 3k I1 will cancel out with each other, and sum of these two remaining equations will become minus 9k I2 plus 16.5k I3 equal to 8 volt. Now in order to omit I2 from these two equations, we will multiply this equation with 2 and add that resulting equation into this equation. So this equation will be taken as it is and we'll multiply this equation with 2. The resulting equation will become minus 18k I2 plus 33k I3 equal to 16 volt. Now add these resulting equations together. 18k I2 minus 18k I2 will cancel out with each other. 33k I3 minus 13k I3 will become 20k I3. And on the other hand side of equal, the sum of 14 volt and 16 volt will become 30 volt. Now in order to find the value of current I3, divide on both sides with 20k. The value of current I3 will become 1.5 milliampere. After calculating the value of current I3, we are able to calculate voltage across this 6 kilo ohm resistance that are labeled as V0, and these voltage will be equal to I3 multiplied by 6 kilo ohm. Replace current I3 with its value. V0 will be equal to 1.5 milliampere multiplied by 6 kilo ohm. That will result 9 volt. So the value of voltage across this 6 kilo ohm resistance inside this network is 9 volt. So this was the last learning assessment of chapter 3. In upcoming videos, we will start solving the exercise problems of chapter 3. Thank you. See you again in next video.